Good morning, students. Welcome back to geometry class today. Hope you guys are doing well on this wet Tuesday morning. And here we go. Let's go ahead and start taking some notes here. Well, actually, first of all, I've asked you guys to be patient with me. I will try to become more and more creative as the year goes on. But I'm going to go ahead and be redundant and do again today what I did yesterday to give you guys some more bonus points. And if you're setting well on your bonus points, then don't worry about that. I still want you to work the problems just for practice and review. So if you would please turn in your books, and again, you be patient with me. I will become more and more creative and get you guys involved individually. I will call out your names and have you do certain problems and stuff like that. But right now we're going to do similar to what we did yesterday. So please take your books and turn to page 263 if you would please. I would like you to look right here, numbers 1, 2, and 4, and you must get them right, okay? All three of them to get just one bonus point, all right? So I want you to do numbers 1, 2, and 4. They're relatively quick, pretty easy. You must get all three of those right for one bonus point. And then do number 5 for a bonus point, number 6, and number 7. Each of those is worth one bonus point. So go ahead and pause the video. Please work on these for a couple minutes. You're allowed to use your notes. You really shouldn't help each other. That kind of defeats the purpose of the bonus points. And then I'll pause this video. You go ahead and pause the video right now and then restart it when you're ready to listen to these problems worked out for you. Okay, hope you guys did really well, and we are on number 1, problem number 1. And I should already be on that page, and I'm not. Hold on one second, please. Page 263. Okay, can we prove or state that these two triangles are congruent using angle side angle? I strongly encourage you students to start splitting up your triangles like this. It might help, and I definitely encourage you guys to do that. So here we go. We already have a right angle here and a right angle here, and a slash here, and a slash here, and a slash here, and a slash here, and we're looking for angle side angle, and I think I see it. Is everybody watching? I've got this angle right here congruent to this angle. They're both 90. And I've got this side here congruent to this side here. So now watch, are you ready? Here's my angle, here's my side, and here's my angle. Well, look back up here, guys. Aren't these two angles right here vertical angles? I'll put a dot here and a dot here. Vertical angles are congruent, so I can state that those two angles are congruent. So look at that. I've got angle, side, angle, 2 slashes here, congruent to angle, side, angle. So yes, you can. Most definitely. We're going to drill this stuff in your heads over and over and over until you're seeing triangles in your sleep, okay? Let's take a look at number 2. Can you prove that these two triangles are congruent using angle, angle, side? Well, yes, students, please watch carefully. Yes, we can. We already know that we have a slash here and a slash here, and we know we have 2 here and 1 here. We know we have a right angle, and we know we have a right angle. Now look, in order to use angle, angle, side, that means we need an angle, then an angle, and then a side. Now, Mr. Earhart, we have this side right here with 2 slashes. I see that. I understand that. But look, we just said a second ago that this angle here is congruent to this angle here. They're vertical angles. So let's come down here and put that and put that. Now I'm going to circle with the color of green here what I have. I have an angle, then an angle, and then a side, congruent to an angle, and then a side. Mr. Earhart, you skipped that side right there. Well, I can do that as long as I have this angle, and this angle, and this side congruent to this angle, and this side. So the answer is yes. I can state that these two triangles are congruent using angle, angle, side. And then lastly, number 4. Number 4. The answer to this, I'm going to go ahead and tell you, is no. Okay? There is no way. Let me go ahead and put 2 slashes here, 1 slash here, 2 slashes here, 1 slash here. There is no way that I know of, that I can see, that you're going to be able to state that this side right here, LM, is congruent to this side here. There's nothing we can do. Now they could be congruent, but we don't know for sure. So because we cannot put 3 marks here and 3 marks here, we cannot do that. Because we cannot do that, we cannot use side, 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 no. Again, I'm not saying the triangles aren't congruent, they might be, but they cannot be proven congruent by using this theorem right here. Cannot do it, okay, or postulate, whatever that is. Okay, let's continue on to number 5. Number 5, they're asking you here, can you state that these triangles are congruent? And if you can, what method did you use? Now, there could be more than one answer. I'm going to go with this right here. Let me get my eraser and erase that. I kind of had the hidden ink going on there. And now we have A, D, C, and A, B, C. Now, it looks like to me we have this angle, or this side here, AB, congruent to DC. Now students, that's all we have. Look, I know that if this line here was parallel to this line here, we could state alternate interior angles congruent, and we could say if I had this line here parallel to this line here, but we don't have any of that. And you might not have thought of that anyways, but no slam intended. But I'm just simply saying, look, all that we have is one side congruent to one side. I don't see any way that I can state any other angles or sides congruent. So no, these triangles might be congruent. They might be, but I can't state it for sure using anything that I've learned so far. Okay, number 6. Let's see what we've got here. We've got a side congruent to a side, angle to angle. Looks like to me we have, now watch this, angle, angle, side, congruent to angle, angle, side. Look at that. So yes, you can definitely state these two triangles are congruent. Angle, angle, side. That's for 1 bonus point. And let's come down here. I hope you all will get used to doing this. I believe in splitting triangles up like crazy. So, excuse me. Fix that right there. Alright, so I have split these two triangles up. I have S and a T and a U, and then a T and a U and a V. And if you look up there, we have 2 slashes here, 2 slashes here, 1 slash here, and 1 slash here. You guys are starting to get good at that. I'll bet you right away you're saying yes, all excited, woohoo. Look, TU right here, they both share the same side. So we know that this side here is congruent to this side here. So look what I've got. I've got angle, side, angle, angle, side, angle. So yes. How? What reason? Angle, side, angle. So please add up your bonus points quickly and put them in the back of the book. Remember, you can always slow me down by pausing the video, but you can't speed me up. So I'm going to keep going pretty fast here. All right? So because you can always pause it, I'm going to move on. Pause the video if you need to. This is our heading for today, guys. We are moving on. I love y'all enough to make you work and to make you understand this math. Okay, so we're looking today at our last way, no cheering allowed, our last way to prove that triangles are congruent. And we're going to do this by a method called HL. Okay, so please copy this into your notes. Today's the 15th, lesson 5.4, and we're going to prove that triangles are congruent. All right, let's continue on. I'd like you to copy this in your notes. You need to have this. Okay, there's the theorem. There it is. Copy this down, please. Theorem 5.2. It's called the hypotenuse leg theorem, thus the letters HL. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the two triangles must be, they must be congruent. Okay, so far we've learned this. We've learned angle, angle, side. We've learned angle, side, angle. I know you're still copying this down. That's fine. And we've learned side, 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 and side, angle, side. Please don't miss this, ladies. These 4 methods could be used on what? Any triangle. Any triangle. Do you see that okay? But this theorem here that we're learning today, please don't miss this, only use this theorem right here on right triangles. If you try to use it on anything else, you're going to hurt yourself, okay? So please don't use this theorem on anything but right triangles. Now, you guys love pictures. I love pictures. I'm a very visual learner, so here's a picture of what this theorem is saying. If you want to copy this in your notes. If you don't, that's fine. If you do, that's up to you, okay? So with that in mind, here we go. Remember, if this is your right angle right here, then the hypotenuse is always the side directly across. So I'm going to say the hypotenuse is congruent to the hypotenuse. And I'm going to say this leg right here is congruent to this leg here. This is so cool. That's all you need. That's all you need. Look at the theorem right here. It says if you have, excuse me, if you have two right triangles, so here's right triangle number 1 and right triangle number 2. If you have two right triangles and the hypotenuse is congruent to the hypotenuse, and that's definitely true, and one of the legs is congruent to another leg, and that's definitely true here, then the two triangles are what? They are congruent. So I can definitely say that triangle ABC. Now watch how you write your congruency here. If A's first, right angle, F has to go next, and then B, so next would be D, and then E over here. So yes, we can state that these two triangles are congruent by HL. Now, I'm telling you guys, we are getting so close to making you memorize proofs. We are going to prove a lot of the theorems. I'm just starting off slow, so I'm not going to prove this theorem for you, but I do want you to sit back, relax, and this will be our standing joke all year, okay? So pop some popcorn and relax and watch the video. You don't have to take notes on this unless you just love geometry so much you want to. So I'm going to I'm going to just quickly show you why HL works, okay? Here's a right triangle, here's a right triangle. This hypotenuse is congruent to this hypotenuse, this leg is congruent to this leg. You already know it, the reason, don't you? You should. What did you learn last year in bridge math? A squared plus B squared equals C squared. I like to teach it like this: L squared plus L squared equals H squared. So think about it. Let's say this hypotenuse here is 5. So this hypotenuse over here is 5. Let's say this leg is 4 and this leg here is 4. If you use Pythagorean's theorem on this, guess what this side would be? A 3. And if you use Pythagorean's theorem over here, you would have to get the same number because the 5 and the 4 right here match the 5 and the 4 here, so your 3 has to be the same. So you know what you have? You have side, side, side. You have 3 sides over here congruent to 3 sides over here. Now some of you are like, forget it, I'm lost, and that's fine, and some of you get it. I just wanted to show you why that works. You are not responsible for this proof, but eventually you will be, okay? All right, let's continue on. Let's take a look now. I want you to turn in your books. Let me glance at my notes to page 258. Would you do that, please? Turn in your books, please, to page 258. Okay, students, I've asked you to turn to page 258, and I just wanted to show you, this is a really neat page in your book. Of course, all pages in all math books are neat, but I want you to kind of look how this lays everything out for you. It shows you the 5 methods. Here's the 5 ways that you can prove triangles are congruent. Please notice this is the only one right here that you have to have right triangles. These four right here, SSS, SAS, ASA, and AAS. You can use these on any triangles as long as you have side, 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 congruent to side, 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 etc., etc., etc. here. This HL can only work on right triangles, but there you go. You now have 5 different ways, of course, contain your excitement, but 5 different ways to prove that triangles are congruent. Okay, it's a really important page. I thought you might want to make note of that, stick a paper clip in it or mark it. That's something you can go back to and look. when you're trying to remember how to prove that triangles are congruent. Okay, we're going to look at two problems, and I'll turn you loose on your homework. Two problems, and I will turn you loose on your homework. I want to warn you, the second problem is pretty difficult. It is a proof, and you've got to get used to more and more and more doing proofs. I'm warning you guys, and I'm trying to build you up to those. Okay, all right, let's take a look first of all at this problem here. Copy this diagram in your notes if you would, please. And I want to know, if you want to write this down, can we prove that these triangles are congruent? Question mark. All right. Well, you know me. I love to split these triangles up. So here we go. Get out the magic eraser, and let me go ahead and write these letters down here. So we have an M, a P, a Q, and then an M and an N and a Q. There we go. Okay. And let's go ahead and put our 90 degrees here, our 90 degrees here, mark here, and a mark here. Now, can we prove that these triangles are congruent? Well, here's our options. We can use side, side, side. We can use side, angle, side. We can use angle, angle, side. We can use angle, side, angle, and hold it. Do we not have right triangles? Yes, we do. So we can also use hypotenuse leg if we need to. That might come in handy. So let's see. Oh my goodness, that's it. That's it. Look at this. Do you see how we have this side here congruent to this side here? All right, do you see that? Well, those are called legs, so we know we have a leg congruent to a leg. Well, look at my pen, please. All that I need for right triangles is the hypotenuse to be congruent to the hypotenuse and a leg congruent to a leg. Well, I just showed you the legs. This leg here is congruent to this leg here. But look at this right here, MQ. Do not the two triangles share that side? So MQ here has to be congruent to MQ here. And what is MQ? It's the hypotenuse. What is MQ right over here? It's the hypotenuse. So we have the hypotenuse congruent to the hypotenuse. Do you see that? So we have a leg congruent to a leg, a hypotenuse congruent to a hypotenuse. We have two right triangles, so we can definitely state that these two triangles are congruent. Here's my answer right here. Yes! Exclamation point. Smiley face. Woohoo! Because we have HL. That's the reason. So we can state the triangle MNQ is congruent to triangle. Now be careful. Oh, be careful, be careful, be careful. Please watch this. What letter comes first over here? M. Do you see that? Right here, this angle right here. Do you see how this angle is on this line here with the right angle, the one slash right here? Well, look, here's the right angle and the one slash. So angle M here lines up with angle Q over here. It's real important that you see that. Very important that you see that. What's the second letter? N. And N's the right angle. So what's the right angle over here? P. And then of course the only letter in this triangle we've not used is Q, P, M, the letter M. I hope you might want to rewind this and watch that congruency again. It's very important. If you don't write your congruencies right on tests and quizzes, I am going to take points off. You have to have those right. Okay? And now ever since I told you the second problem was going to be a two-column proof, I know you immediately slid forward on the edge of your seats with excitement. So without any further ado, let's go ahead and do this two-column proof. Would you write this in your notes, please? Here is your given. Right here. Here's your given. PR is perpendicular to SQ, and PQ is congruent to PS. All right? And we're going to prove that triangle PRQ is congruent to triangle PRS. And you're probably thinking, no, I'm not going to prove it, Mr. Earhart. You are, but I'm not. And that's fine. We'll kind of continue to work through this and hopefully get any fears that you have over two-column proofs worked out of your system. So let me go ahead and set this up. You can be doing all this too, students. You're going to have to do this whether you want to or not. This is geometry, and I'm not being mean, but it is what it is. So we've got to do this. Okay, statements over here and reasons over here. I'm going to let you guys do something I allowed all my students at Tennessee Temple to do when I taught geometry. And well, first of all, I'm getting the cart in front of the horse, so hold on a second. So does everybody have the diagrams drawn? Hopefully you do. And you should have your statements and your reasons columns set up. Okay, the first thing you really want to do, students, is come over here and I told my students all the time, take your given and put it on the diagram. So are you ready? I know that PR is congruent to SQ. So here's PR right here. See my pen? And SQ. So I know I can put perpendicular symbols right here. All right, there's my perpendicular symbols. Is that okay with everyone? Look what else I have right here. I have PQ is congruent to PS. Okay. So PQ, put 1/ here, is congruent to PS. There we go. Okay. Now, let's take a look here. What I told my students at Tennessee Temple, I thought it was so redundant to take this given, and Miss Walker might not let you guys do this, but I'm fine with this. I always told them to put the number 1, put a dot, and just put a / there, and then come over here and put given. I saw no reason, personally, to pick this up right here. Well, I'm probably trying to get too fancy here, but I see no reason to pick this whole thing up and put it right here. That's just, to me, it's already written right here. So in my class, you are allowed to put a / here and then go ahead and write the word given. Okay, and we've already picked this up and put it over here. So okay, we've picked our given up, we've put it on our diagram, we've put in the / wrote the word given. I like to tell my students we're going to lay out a plan of attack. Okay, so we're going to lay out a plan of attack. You can put this in your notes wherever you want to. I'm kind of limited on space, but I'm going to lay out a plan of attack. Here's what I'm going to do. Think about this. Okay, I notice I have this. I have right triangles, right? Here's triangle number 1 and triangle number 2. They're right triangles. Why I'm whispering, I have no idea. And now look, PQ is a hypotenuse and PS is a hypotenuse. So I know I have an H congruent to an H, right? Sure I do. And now look, they share side PR. They share that side. So I know I have a leg congruent to a leg. So I can definitely state that these two triangles are congruent by my new theorem, HL. Okay? So now I've got to get all of this down here. So you're probably like, oh, dude, let's just do, well, hold on, let's relax. All that we know is we have perpendicular lines and congruent lines. We have nowhere in our given that we have right triangles. So let's just stop and let's think this through, okay? When you have perpendicular lines, are you listening here? When you have perpendicular lines, that means you have right angles, correct? So I'm going to go ahead and write right here, angle QRP. Now watch my pen. That's this angle right here. Put a little dot right there. QRP. And angle SRP. SRP. This angle right here. What can we say about those two angles? We can say those two angles are what? They are right angles. How do I know that? Do you remember learning this first semester? I hope you do. The reason is perpendicular lines form right angles. Okay, so there we go. That's my reason. Well, Mr. Earhart, how did you know you had perpendicular lines? Right here. Look at my given. Perpendicular lines. Okay, now that you've stated in step 2 that we have what angles? Right angles. Now we can state that we have right triangles. So now I can state that triangle PRQ and triangle PRS are what? What are they? They're right triangles. Well, how do you know that, Mr. Earhart? Well, definition of a right triangle. Remember, the definition of a right triangle is a triangle that has a right angle. So as soon as I stated that I had right angles, I can then state that I have right triangles. Man, we are so cruising. Look at this. We have stated we have right triangles. Look at our given right here. Remember what our given says? Our given says this. PQ is congruent to PS. Do you see that right here? What is that? Aren't those our hypotenuses, if there is such a word? Hypotenuse, anyways, I don't know. But now we can state that we have PR congruent to PR. Remember how PR, they share a side? PR is congruent to PR. And I'm getting a little old. I think we call that the reflexive property, don't we? I think we do. I should have checked, but I'm 99% sure that's called the reflexive property. So there's the reflexive property. And now look what you've stated. And now watch this, students. Have you stated that we have right triangles? Yes, you did, right here. Have we stated we have hypotenuse congruent to hypotenuse? Yes, you did, right here in your given. Have we stated that we have legs congruent? Yes, we did, right here. So we've stated we have right triangles, we've stated we have congruent hypotenuses, we've stated we have congruent legs, so we are definitely ready now to state that we have congruent triangles. So triangle PRQ is congruent to triangle PRS. And what is your reason for that? HL. Well, back it up, listen to it, meditate, hum, find your inner child, whatever you need to do. But that's how you do that. We're moving on. There's your homework assignment. Now, while I'm rambling, I would like you students to please turn to page 260, 261. Actually, I want to talk to you about numbers 15 through 23. So would you please quickly turn your books to page 260, and I want to talk to you guys about numbers 15 through 23. Okay, I'm back. Here we go. 15 through 23. Now, all that I wanted to say to you is this is a great exercise. You have a total of 12 problems. I know I've given you all of them, and I know that at this point in time you're throwing objects at the screen, but you need to practice. And I'll be honest, I think you'll get more than half of these done in class, and you'll probably have about 4 or 5 to do tonight. But these problems right here, you're allowed to use any of these methods that you've learned. That's why it's so important you do a lot of these. You need to practice, okay? Like it or not, you need to. And so they're not proofs. You're not doing 2-column proofs. You're just stating whether or not these triangles can be stated congruent. Now remember, if you don't have a right triangle, then don't use this one. And if you do have a right triangle, you can use this one or these. Okay, so there we go. Hope you do well. The video you'll want to look up tonight at home on YouTube will be, you got to figure it out by now. It's Berean space Academy Geometry 5-4 homework. And really proud of Tara. Tara emailed me yesterday and said, hey, she missed class. She was watching the video at her house and her homework. So now that I've embarrassed her really good, that's a good job. That's what the videos are there for. And Ashley, I did get an email from Mr. Harmon telling me you were absent last week. So I will be going into Sycamore and changing your 0 on a homework assignment to an incomplete. Please get that in as soon as possible, okay? All right, that is it for today. Please get to work, help each other, and use the video tonight at your house to check your homework.